Hello everyone, this is Professor Iris Miano again with a lecture video helping you out with your Day 2 things. This is for my Math 2 plus 2C audience at Santa Monica College. So we're going to be talking about multiplication of polynomials. We're going to get into some very preliminary terminology and identification of things, all that. And then I'm going to have you multiply some monomials with me. We're going to multiply a monomial with a polynomial, and then we're going to multiply some polynomials together. And I will go into strategies outside of the FOIL strategy for multiplying two binomials together. That's a discussion for another time, although I could go over it in class at this time per your request. Okay, and by at this time I mean the next time we meet in class if you're watching this outside of class. Great. Let's talk about a basic exponent rule that we really need to make sure we are aware of when we're multiplying polynomials. Like if you have two monomials, like a to the m power and a to the nth power, and you're multiplying them together, you will use the product rule for exponents, which basically states that as long as the bases are the same and you're multiplying two exponential expressions together with that same base, then you add the exponents together. Okay? Great. So quick, just very preliminary practice on that. Notice in my examples I, J, and K, we're starting on I, J, and K for some reason, all of the bases in these multiplication problems are the same. So simply add the exponents together. So for example I, you'll get 7 to the 5th power, which, you know, you could use your calculator to determine the value of that. Just keep it in exponential form for our purposes. For example J, this R has an invisible exponent of 1, so the product rule for exponents will dictate that it's an r to the 5 plus 1 power or r to the 6th power. Lastly, for example K, add those exponents of 6, 2, and 3 together and you'll get w to the 11th power. Okay, cool. Now, let's go ahead and implement this rule with some monomials, okay? And in order to do this effectively, we need to practice that product rule. So, but also there's other components to these monomials, and that's the coefficients. Those just need to be multiplied together the way you already know how to. So if we want to, we can regroup the individual items, just drop the parentheses all together and regroup the coefficients together, maybe keeping some parentheses around that -2 factor, and then putting the x, the variable components last. So you'll multiply the coefficients together and use the product rule to combine the variable parts, and you should get -12x to the 12th power, because 6 times -2 gives you the -12, a coefficient in the final answer, and then 3 plus 9. Adding the exponents according to the product rule gives you that 12 exponent. Okay, let's do it again for example M. M's and N's abound, so go ahead and regroup them either explicitly on your paper or in your mind. Recognize that this m right here has a secret invisible exponent of 1, and then implement that product rule and you'll get m to the 6th power, n to the 26th power. Okay, moving on. So there's also the power rule for exponents that we'll need to review in order to deal with that whenever it comes up. So if you have an exponential expression raised to an additional power, you will multiply the exponents in order to simplify them. That's the power rule. All right, let's practice this real quick, and of course keep these in exponential form even if they could have a numerical value otherwise. Power rule here would dictate we multiply the 4 by the 10 in example N here, so we'll get 9 to the 40th power. Here for example O, we'll get Z to the 18th power, right? Multiply them together. For example P, we'll get -3 to the 20th power. Go ahead and keep that -3, like I said, parenthetical, and leave it as an exponential expression. Okay, now let's go ahead and talk about power of a product rule for exponents. We need to recognize that we have a product raised to a collective power. It's kind of like you distribute that exponent to each individual factor inside that product. Okay, and let's practice this here. For example Q, that 7 exponent outside of the product between x and y just gets distributed to individual components. It'll be x to the 7th power, y to the 7th power. there. For example R, we're going to distribute that exponent of 4 to the 3 and the y. And then 3 to the 4th power is something relatively small as far as the base and the exponent values are concerned, so we can simplify that a little bit. 3 to the 4th power is an 81, and so we're going to simplify that to an actual numerical value. Okay, moving on to example S. Take that 3 and give it to not only the -2 coefficient out in front, but the p to the 4th power, q to the 2nd power, and r, and it's going to initially look like this. Now the -2 to the 3 power, again, because the coefficient value of -2 and the exponent are relatively small, we will simplify that all the way down to a numerical value, and then we're going to need to implement, it looks like the power rule here and here, and then the exponent of 3 just gets affixed directly onto the r, which initially had an exponent of 1. It just kind of gets replaced, or you can think of it as r to the 1st power times the 3 exponent that's getting distributed. Okay, simplify there according to the power rule, and you will have the following final answer. All right, very good. Cool. So now, remembering all of those these exponent rules, we are now ready to multiply some polynomials, okay? So when you're multiplying monomials, you're just going to rearrange the factors and remember your exponent rules. We kind of already did this in some preliminary examples in this video. Let's go ahead and do it again. So for example A here, we're going to be rearranging the factors. The coefficients go in the front, the variable factors go in the back, and multiply the coefficients and use the product rule on your variable parts. And there you have it, all done. Let's do the same for example B. Rearrange all those factors, implement the appropriate rules, and you are finished. For example B, do remember that the single factor of x has an exponent of 1, and so it's 1 plus 4 plus 7. That gives me the exponent of 12 on the collective exponential expression at the end. Okay. Now, when we're multiplying a monomial by a binomial, we'll use the distributive property. Okay, so it's like this. For example, C, this 8x is going to be distributed to the 7x to the 4th and to the 1, like so. So it's like each of those individual terms gets their own factor of 8x, and then you rearrange the items accordingly. I'm just going to show you the final answer there. Oh, excuse me, let me go back a step. So there is some detail that's missing here. If you want me to show a little bit more detail in class and go over these examples again, any example that doesn't show enough detail for you personally in the lecture video and you'd like to see a little bit more of the steps, please do not hesitate to ask. It's something that I definitely enjoy doing in class per your request. Okay, but this is the final answer right here. Same thing, but different example for part D. Go ahead and distribute that -2x to the 3rd power. Now, whenever you're distributing a negative factor over some quantity in parentheses, it's going to change the sign and operation of all of the factors, all of the terms inside. So make sure you're very careful when you do that there. So explicitly writing that factor, like sliding it in between the operation and the term, right, that's present in the original set of parentheses, I think is the way to go. I would write it this way. And then, of course, you do your simplification, and this is what you get for your final answer. Again, I am skipping some steps. Just let me know if you'd like to see a little bit more for, I don't know, example D in this lecture video when we meet in class. Now multiplying polynomials, okay, you could either use the distributive property that we just saw there, but it could get a little bit messy. And there's also a vertical method as well that some textbooks have. But I've found that the area diagram is probably one of the easier ones to use outside of when you have two binomials multiplied together. Obviously, I would recommend that you use the FOIL method, which is something that gets talked about in other areas here. We could talk about it in class as well. And in fact, my very first example here is an example E, as you see in this video here. It is two binomials being multiplied together. So certainly you could use FOIL, which stands for firsts, outers, inners, and lasts. You know, that's a perfectly good method here. What I want to demonstrate for you is a generic method that you could use for multiplying any polynomials. So, you know, trinomials, polynomials with 4 or more terms, it can get wild, right? So if you use this area diagram, which is basically a box with the number of squares associated with all of the possibilities of multiplying here. So basically it's like however many terms you have in your first polynomial, that's how many rows you need to have. However many terms are in your second polynomial, that's how many columns you need to have. Okay, so rows go horizontal and columns are vertical representations here with this area diagram. Okay, so go ahead and it doesn't matter which polynomial you decide is representing the row headers versus the column headers. You just need to make a decision. So I've decided that the first polynomial of 4x plus 5 would be my row headers. So 4x gets represented by this entire row, 5 gets represented here. And then my second polynomial of 3x minus 4, those two terms of 3x and negative 4, remember, sign comes along for the ride, are represented as my column headers. Now, in each individual box, you're going to put the product of the row and the column that's associated with it. So you'd fill it out accordingly. Okay, right? 3x times 4x is what's populating this first box with 12x squared there, okay? And so on and so forth. You will notice sometimes that the diagonal contains like terms, and that's something that you can add together like on the fly and just kind of present your final answer in the next step, which in this case would be 12x squared minus x minus 20, because 15x minus 16x, or 15x plus a negative 16x, gives you a negative 1x, just call it negative x. Okay? Now let's get into some more challenging examples here, like multiplying a binomial times a trinomial. So you're going to have to give yourself a different style box. I went ahead and said that my first polynomial, my binomial, was going to be my column headers. That's why I have 2 columns and I have 3 rows. Okay, so you would label your columns and your rows accordingly because of the way I drew this box. Certainly, you could also draw an alternative box that has 2 rows and 3 columns, and you would just label them the inverted way compared to this, okay? And remember, sign comes along for the ride, and that's why the middle row has a negative 5x rather than just a 5x, okay? You gotta have that signage in there. Go ahead and fill out your box according to the product of each row and column. So this very first box is gonna be what? 2x squared times x, otherwise known as 2x cubed, and so on and so forth. So everything gets filled out accordingly. And again, notice on these 2 diagonals, there are like terms. Combine them as you go and write down your final answer. All done there, okay? And that's it. Let's do another example here. Let's do a trinomial times a trinomial. So for this, you'll need 3 rows, 3 columns. For your area diagram, I labeled them accordingly. You could have them inverted. That's fine. You're still going to get the same final answer. Fill in your box by putting all of the products for each row and column in, and there they are. And yeah, you might want to pause the video at various points in order to fill yours in. I'm kind of going through this quickly, but it could warrant some pausing. And notice again on these diagonals, you're going to have like terms. Here's all your x to the 3rd power terms, here's all your x squared terms, here's all your x terms. And the x to the 4th term and your constant term are the odd man's out, nothing to combine with those. But you could just look at these and maybe do some mental math, or feel free to definitely write it down if that helps at all. And you could write down your final answer from there. And that's it. You are now ready to multiply some polynomials. So go for it, and let me know if you have any questions in class. Thank you so much.